17, similar problem to number 16. That is 3y 13 over 5 power. 3y 13 over 5 minus 22y to the 8/5. And then plus 7y to the 3/5. All that's equal to 0. Okay, so it's kind of too close to the top. All right. We're going to do the same process. We're going to factor out what they have in common. We're going to reduce the radicals and then see if we have quadratic. So 3, 22, and 7 are relatively prime, so I cannot factor out any number. I can factor out a fifth and 3/5 to be exact. So I'm going to factor out 3/5 from each term. So y to the 3/5 power. When you factor out exponents, you got to remember you're subtracting. Okay. So I'm subtracting 3 from here, so it's going to leave me 3y 10 over 5 minus 22y, take away 3, that's going to leave me 5 over 5, and then take away the 3/5, it's going to leave me with 7. All right, we're going to reduce those. 10 over 5 is 2, 5 over 5 is 1, so that'll give us quadratic. Y to the 3/5, and then 3y squared minus 22y plus 7 equals 0. Alright, we're going to factor 7 times 3, or 3 times 7 is 21. Factors of 21 then add to give you 22. It's going to be the first factor, 1 and 21. Alright, so we'll factor y to the 3/5. We're going to put a 3 out front of each because I don't know where it goes. We're going to fix that later. 1 and 21 at the back. First sign is a bigger number, so negative, and the second sign is positive, means they're going to be the same, so both of them are negative. We want to reduce. 1 and 3 we cannot reduce, so we're going to leave it. Y to the 3/5. So 3y minus 1 will stay. And then 3 and 21 can be divided by 3, so we're going to divide those by 3. That's going to leave us with y minus 7. So here we're completely factored and correct. With this guy, it's going to be 0, 3/5. But the way you can do that is raise it to the 5/3 power. Just multiply by the opposite. Do the same thing on the other side. You can also convert it to a radical, but either way you're going to get y equals 0. And then we have 3y minus 1 equals 0. We're going to add 1. So 3y equals 1, divide by 3, y equals 1/3. And then the last one, y minus 7, you add 7 to both sides and you get y equals positive 7. And positive 7. Okay, we'll go ahead and do 18 here. This one again will be the same type of problem. We're going to be subtracting the exponents, and then it's also combining this fact that we have the expression instead of just a single y, but this is going to be acting like your y. So we can use substitution if we like. That may help. So let's just say, just for simplicity, for number 18, that this 3y minus 2 is going to be equal to x. We're going to replace it with x. So I'm going to rewrite this problem as this: x to the 2 over 3 power, and then minus 3x to the negative 1 over 3 power, and that is equal to 0. Okay, so I'm going to factor out, they both have this x to the negative 1/3. So you got to remember, whenever I'm factoring out, I'm subtracting exponents. So just a side note, if I have 2/3 and I subtract a negative 1/3, what happens, negative negative becomes a positive, and then this ends up adding and it becomes 3 over 3. And 3 divided by 3 is 1. So that exponent is just going to become 1. And so I want you to see that. That's what's going to happen. I'm going to factor out an x to the negative 1/3 power. That's the smallest number. You can always factor out the smallest. This is going to leave us with just x and then minus 3 equals 0 because that x to the 1/3 came out. So I just did the little side work. So this is what happens when I factor this out. Okay, so now at this point we're going to just set both terms equal to 0. Okay, so x to the negative 1 over 3 power equals 0, and then x minus 3 equals 0. Now we didn't start with x, so at this point, once I have it simplified, I'm going to go back and replace it with the 3y minus 2, what we started with. So this is 3y minus 2 to the negative 1/3 power equal to 0. And then this is also 3y minus 2, and then minus 3 for that extra minus 3 equals 0. So we're going to simplify, solve, and then we'll be done. Negative 2 minus 3 is going to give us a negative 5. So we'll do that side first. 3y minus 5 equals 0. We're going to add 5. It's going to give us 3y equals 5. And then divide by 3, so you get y equals 5/3. That is our solution there. Okay, so even with this negative exponent, I can raise it to a power. So I'm going to raise this to the negative 3rd power. Negative will cancel out the negative and divide by 3. Do the same thing. Anytime you raise 0 to any power, it's going to be 0. So it's going to get rid of that. So I'm going to have 3y minus 2 equals 0. We're going to add 2. 3y equals 2. And then divide by 3. And that gives us y equals 2 divided by 3. So we get 2/3 and 5/3. And it looks like we're going to need to check. We have one box, so we need to verify which of these work. Go back and check and make sure and see which one works. So I'm going to start with my original problem and write it down all the way since I never did. So we have 3y minus 2 to the 2/3 power, and then minus 3y minus 2 to the negative 1/3 power. Alright, so I'm going to plug in the 2/3 first. So if I plug in 2 over 3, over 3 as well. Alright, so 3 will cancel out. We have 2 minus 2, which gives us 0. 0 to any power, this is 0. And then over here, same thing is going to happen inside. This is going to go to 0. Raise to any power, 0 minus 0 equals 0. So 2/3 appears to work fine. Let's try 5/3 and see if we get the same thing as 0. So I'm going to do 3, and then it's going to be 5/3 minus 2. And all of this is raised to the 2/3 minus 3, and then we have 3 to the 5/3 minus 2 and this raised to the negative 1 over 3. Okay, so inside parentheses first, the 3 will cancel out 3. 5 minus 2 is 3. So we have a 3 to the 2/3 power, which means we're going to square it and then take the cube root. And then over here, minus, this 3 is on the outside, that's going to be a 5 minus 3. So we have 3 raised to the negative 1/3 power. Alright, simplifying this, we will, let me just rewrite them both. This is going to be 9, so I'm going to square the 3, that's going to give us 9. It's going to give us the cube root of 9, and then minus 3, and then this negative 1/3 is going to move it down in the denominator, so I'm going to have 1 over 3, but then this gives us the cube root of 3. So this is what we're looking at, and from this point I can continue to simplify, but I'm just going to plug in the calculator and see if this gives us 0. See if this equals 0. So the calculator can at least give us that number at that point. So on the second quit, I'm going to do cube root. It's not 3 times 9. I kind of wrote that bad. This is actually the cube root of 9. So I'm going to go to math. I'm going to arrow down to option number 4, or just hit 4. And I'm going to put a 9 here. And then we're going to subtract 3. And instead of writing it like this, I'm going to write it as 3 to the negative 1/3 power. I'm going to do 3. We're going to raise it. Negative 1 divided by 3. And that gives us 0 as well. So it looks like they both work. Why did it only give me 1 block? Let me see. Divided by 3. This is weird. I only took that one. I don't know. I don't know if they're only going to take the one with the real response. I mean, like, because of the negative exponent. But it looks like they both work. I mean, based on plugging it in, they both came out to be 0. So I would just advise when you get to this problem, the answer that you get with your negative exponent, to, I guess, throw it out. But I'm not seeing a reason why mathematically. So use a real one, the one that doesn't have the negative exponent, and then you should be okay there.